So the idea that we wanted to try was to kind of give a short talk that we thought would be maybe interesting to the sysadmin type community, people who might be running their clusters or they're providing resource to the open science pool, the OSPool. I've decided that I want to give a talk called "Why is my site not running jobs?" This happens to be a favorite question, and hopefully, as you'll see, the system's complicated enough that it's not actually always a easy question to answer. As I was preparing for this, I have to admit, I started thinking about what it takes to listen to yet another set of PowerPoint slides. And I think I have given enough PowerPoint presentations over the last 2 years to fill many decades. And I decided instead, being that I'm a mathematician at roots and I prefer working in front of a chalkboard, I was going to try to do a chalk talk. So, like a somewhat normal office hours, or if I actually was in front of a chalkboard, feel free to jump in. I try to structure this a little bit so there's different pieces where you could start to ask questions or join in. It's because I purposely am not reading from a PowerPoint deck, I hopefully will kind of encourage that a little bit more. If we get to it, I am going to try to be quiet after about 20 minutes. I want to go over 3 different parts. Kind of the first part is I want to talk through a little bit what I mean by OSG and the Open Science Pool and kind of how these pieces fit together, because it's, I think, always something that even though those of us that have been working with it for 10 years kind of forget, it is a bit overwhelming. Part 2 would be what could possibly go wrong. And I want to talk a little bit about things that commonly break or things that we've been seeing kind of go haywire at the site side. And then part 3, and this is where it gets iffy if we'll have time, I wanted to kind of show you what our internal monitoring looks like. And finally, of course, if you ever want to reach out, help at opensciencegrid.org. All right, so overview of the OSG and the Open Science Pool. So first of all, when I say OSG, I'm really thinking about what we call the OSG Consortium, which we often describe as a partnership or a group of like-minded individuals, participants, and not necessarily members that are working to advance high-throughput computing or distributed high-throughput computing for open science. So the OSG Consortium has a council that leads it. The council picks out an executive director. I think many of you have met Frank Werthwein. And other than that, it's all up to all up to the director. So right now, there's 2 big projects that participate in the OSG Consortium as funded NSF projects. There's a number of other participants who give time, say from Fermilab, as part of their in-kind contributions. But most of you have probably seen the words PATH, Partnership to Advance Throughput Computing, and IRSEP, which is a funded software institute that works on HL/LHC issues. So in addition, there's a bunch of other ones that I don't want to quite go through the whole listing here. So we have the OSG. It's a group of like-minded individuals. And the OSG Consortium provides services. So some of these services are hidden under the cover. Some you see every day. These can be software services, such as the software stack Brian Lynn's in charge of, or services that are responding to things on the internet. Perhaps the most visible service that we have are different resource pools. So we have one resource pool called the OS pool. I'll talk a bit what I mean by resource pools in a second, but I did want to mention that there's a bunch of others. So we have the OS resource pool. There's one for IGWIN. There's one for JLab, so on and so forth. So even though I'm going to kind of be specific about the OS pool today, I did want to mention that there's other pools and that, of course, there's other services beyond the open science pool or the resource pools themselves, but we're going to do this one for today. So what do I mean by a resource pool? So the analogy I usually like to make is if you wanted to build a cluster in Amazon. So let's say we're living out in AWS. You might fire up one particular virtual machine type to be traditionally, we call these head nodes if you're running from a batch system, but within the software package that we use for these HD Condor software suite, we call these the central managers. So you might go out to Amazon and say, fire me up one central manager. And then you'd say, I want you to fire me up a bunch of batch worker nodes, which typically within the OSG, we've been calling these execution points. So we have central manager and execution points. And then we tell the execution points, here is where to find your manager. So we call this set of resources a resource pool. And that's basically what we are trying to offer with folks, except, of course, nobody here is Amazon. And just like you might say, oh, gee, I want to pull in resources from Amazon and GCP. We might put a couple execution points here. We are working with multiple resource providers. We're working with Georgia Tech, we're working with Utah, we're working with Fermilab, we're working with Nebraska, we're working with Wisconsin, wherever these might be. And of course, instead of having whatever the GCP API is, or the AWS API, EC2, to get into these clouds, we have a different set of, or a different way to get inside the door. So this is how you would do this in maybe a very cloud-centric case. But the analogies are the same when we start doing this on the OSG. So I can pick a different color here. So let me see the two top folks that I can see in my participant view is one is from CU Denver, and one's from Georgia Tech. So let's draw Denver. And let's draw Georgia Tech. Now, just like with Amazon or GCP, what we want to do is go out to these two resources and ask them for worker nodes or execution points, and then to add them to our resource pool. So we have our central manager for the OS pool. And then we need a component that goes out and talks to all these different points to allocate the resources. So within the OSG, you can see us call these factories. People that are really good with drawing, which I'm not, draw smokestacks or something like this, which is probably not very environmentally friendly if you think about it. But our factories somehow have to talk to Denver and somehow have to talk to Georgia Tech. So instead of having the EC2 API, we have what we call the compute entry point, the CE. And this provides an external API that can be used to allocate resources from their batch system. So Denver has a batch system, Georgia Tech as well. Maybe Denver's Slurm or Georgia Tech is Condor. We try to be relatively independent of this. And because the CE is actually kind of a big load of software to run, one thing we even allow sites to do is have us run the CE, and at the site, just needs SSH. So all the OSG specific services and software that you have to learn stays on the OSG side, and what sites really have to do is talk SSH. Some sites do this, some sites don't. It looks like, I think I even picked correctly 2 sites that do and don't. So this is this basic setup of the OSPool. And of course, this is just how we gather things together. And the big question is, of course, what do you do with resource pool? And this is where we have what we've been calling an access point. Some people call it a submit host. Old school Condor folks call these SCEDs. But this is where our happy users log in. Oh gosh, I'm testing my artistic ability here. But this is where the users log in and they submit their jobs into a database of some sort. And now we can start putting all these things together. The central manager works with access point to understand what sort of resources it has, or jobs that the access point has, what sort of resources the central manager has. All execution points. And the central manager, one of the important things it does is performs matchmaking services. It finds whatever resources are at these different sites that the access point can utilize and run jobs on. So our jobs, maybe live inside this database. And maybe we decided today we have a job that could run at Georgia Tech. So the access point works together with Georgia Tech. So the access point connects to a pool, the OS pool in this case, and then claims the different resources for its scientific jobs. So this is actually a great point to stop and pause and take a breath and see if folks have questions. All right, you guys are being quiet. I should have done some icebreakers. Sorry. So.
Oh, sorry, Brian.
Got a hand.
Oh.
Hello, Brian.
Hey,
Can you hear me?
Yeah.
Okay, how are you doing?
we're cold up here. It's for Texas.
Yeah, it's fine. We're not buried in snow, so it's great. So I had a question about the execution point, which I'm guessing is at the worker nodes. Is that right?
Yeah. So the that's why I started with this analogy of AWS, where it's kind of very natural to say, oh, I'm launching my own VM and I put in whatever I want, and putting in a batch system in AWS doesn't seem so crazy. But similarly, that I'm not drawing the whole time, I can turn on my video. When we actually talk about the OS pool, these are basically batch system worker nodes allocated inside a batch system.
Okay, so is the execution point requesting the access point for information about the job, or is the compute entry point supplying the job information?
Yeah, so that's a great question. So that actually gets kind of into the next subject. So notice the very first thing I mentioned here was the central manager and access point talk to each other about what resources exist and what jobs it has and provides matchmaking. So the execution point tells the central manager about itself. I guess that's step 0. So that, that's kind of one connection out there to the central manager. I think of the central manager as a database of workers, a database of jobs. And the access point is a database, or sorry, a database of workers. And then the access point is a database of jobs. So you notice that at no time does that CE that talks into the system actually hear anything about the jobs itself. The CE just works with the factory to decide on how many execution points to launch. So all the jobs then flow through a TCP connection down from the access point to the execution point. Logically, of course, the TCP connection is not incoming, it's outgoing. Is that what you were asking?
Yeah, I guess my question was related to the outbound network connectivity of the worker nodes. And I think this might play a role as to why that is required, both outbound, because I know there's no login directly to the worker nodes. That's only the CE doing, I'm guessing. CE is the one that's accessing the login node and potentially the worker nodes. The worker nodes don't have SSH access. I mean, nobody has SSH access to the worker nodes, but the worker nodes need access to the job information. So I'm guessing that's where they need the outbound internet access, because in order to get this job information from the access point, is that right?
Absolutely, yeah. So as you can imagine, with NAT boxes and firewalls and topologies and whatnot, the TCP connections are not going this way. Right, that's not going to be possible on most sites. That once the execution point hears that the access point has worked for it, it's going to create an outbound TCP connection to the access point. I'm going to clean that up because it gets a little messy. And our job is going to travel from the access point down here to be executed. So yeah, there's this TCP connection. This is TCP. And then of course the other one to bootstrap all this is this TCP connection.
Thank you. All
right. So that diagram became busy quickly. Thanks to Georgia Tech and Denver for letting me use you as an example. The other piece of the system that I think is really important to understand why your site may or may not be getting jobs is that, switch colors on this side. So we have our happy site. So this is what you get for asking questions. We have a CE that's logically associated with it. I think in that case, we're actually running it OSG. And I drew this beautiful factory that submits the jobs, or we call them pilots. Now, of course, the factory has to decide how many jobs to submit where. And the factory, I left this out of the diagram, is actually a pretty simple, thoughtless process. It ends up just being doing what it's told by another process called the front end that is for the OSPool. The factory gets reused by lots of different organizations versus the front end is just for the OSPool. And the front end has to go to all the different access points it cares about. Some of which you've probably seen in our documentation. There's some that we run called OSG Connect. But many others, we work with a wide range of sciences. And this front end has to tell the factory oh, I think if you give me 10 batch slots from WTAMU, I can use them to get some sort of science done. So there's this connection. And in order to understand how much work that is out there, Frontend has a list of all the different access points it knows about, and it will actually periodically query the access points and say, okay, tell me about all of your jobs and your job workflows. It'll say the factory, tell me about all the CEs you know. And the front end itself also does kind of this matchmaking. It looks at the access points, and then it looks at what's in the factory and tries to make an educated guess about how many different pilot jobs or how many different resources we could successfully utilize at all these different sites. So I kind of think of this as a two-stage matchmaking process. One is the resource provisioning, where we have this front-end component that kind of looks around and says, oh, I think I could use 5 over here, 10 there, 20,000 over there. That then tells the factory, please provision me this list of menu items, which then goes out to the CEs and tries to submit an appropriate number of those execution points. Which of course, then we get back to our central manager and does that same dance as before. So that gets into the second part of my talk, which is what are all the different places this can go wrong? So we'll start with the previous picture. So Anirban, you hit on a really easy one where this could go wrong. Let's see, what color should we use? Okay, black's fine. In order for these workers to go off and offer their services to the central manager, and then to work with the access point to execute jobs, we need a TCP connection. So no TCP connection, no joining the central manager, and no TCP connection, then of course no running jobs for access points. Honestly, this is one of the easier things to catch going wrong, because if this is happening, then you know this very loudly, very quickly. You kind of catch this in the site setup phase. Similarly, we're not actually spawning VMs. We're spawning a bash script, which downloads a bunch of configuration files and the Condor software, and trying to bootstrap this in whatever environment we find at any research computing resource we could find within the US. So it'd be nice if we could spawn VMs, but there's in fact lots of different site configuration options that we're exposed to, and we have to kind of have software that is sufficiently bulletproof, or sometimes not quite bulletproof enough, to actually be able to launch and find its footing at any of these sites. This is, of course, quite hard to do traditionally with bash that executes curl, that downloads this, that downloads that. And as you can imagine, we've been delighted over the last couple of years as we start to get different container technologies that are available that starts to make this a little more durable, even without privilege. So network can fail, or job startups can fail. Job startups, those sometimes can get caught early on in site setups, but sometimes as site switches batch systems, as sites upgrade their OSs, as people apply security settings, these things can actually break later on. But again, even though it's not catching it up front, it's something that tends to either always work or always fail. So early on in any sort of debugging process, we're going to see, were we able to start Condor, get the execution point to launch there? The next thing that starts to become a little more difficult is this picture, where we're trying to estimate what is going, how much of, how many resources do we need at each site? And this can kind of go wrong in two different ways. So we might have our settings wrong for West Texas. And the factory might say, hey, West Texas is a bunch of ARM CPUs running on iPhones, an iPhone 4 with 512 megabytes of RAM. And if we have some of those configuration settings wrong, where how we describe and talk about the sites, of course, our different access points are going to say, hey, I can't use ARM CPUs and I need 2 gigabytes of RAM. Therefore, don't even bother asking for West Texas for additional pilots. So kind of one thing that can go wrong is too few pilots. That can be caused by wrong resource description. Or of course, no matching work. Both of these, I would say, are probably some of our most regular issues, particularly the no matching work one is very hard to diagnose and detect, right? Work goes up, goes down, goes left, goes right. And what we consider matching work can change from day to day. And this is one that we've traditionally really struggled with, making it apparent and obvious what work we have for sites to be able to monitor whether there's anything for them. Because again, the other half of this equation is 2 mini pilots. And this is where we get really grumpy and sites get really grumpy, because if we have the wrong description of the site and send too many pilots, all of a sudden we're now wasting cycles that perhaps could have gone to other useful science resource communities. So for us, this is one I always like to avoid, and we have various monitoring that's getting better every month, I would say, to actually say how many pilots are we asking for, and then how many pilots did we actually use? Did we use what we asked for from the different resources? And the usual cause of too many pilots is a mismatch of the resource description. So for example, oh, Nemo, I see. You can just jump in. You don't have to raise your hand, by the way.
Sorry, I didn't mean to interrupt. This is Memo from Georgia Tech. I think this is a great time to ask my question, which is some confusion I've been having for a while. Can resource pools be requested as if they are requirements? In another way of rephrasing this, we are integrated into multiple pools, big one, IceCube, OSPool.
Yeah.
And so we configured our CE. We have only one CE, which is a little outside of the usual setting, I guess. So we have to first define all of them, and also from the jobs has to ask for the right thing. Otherwise, a request can go to the event pool when it was actually intended for IceCube pool. So is there an elegant or standard solution for this?
Yeah. So one thing, just for everybody else, because I think you actually snuck in 2 questions, which is fine.
Sorry.
One, I think you were asking about the resources, say at Georgia Tech, so this. And another important thing to realize is, of course, you guys are also running your own access point. So that picture is a little more complicated, because your access point, instead of just talking to the OS pool, also talks to Igwin and to IceCube, things like this. So not only do we have that problem of making sure the right things are going into Georgia Tech, but also make sure that the right things at the Georgia Tech access point are getting partitioned to the right pools. I'm going to kind of skip on the second one. So I'm already over time. I don't want to go too much into a rabbit hole. But for the first one, what we do again, we have a resource description here at the factory saying this is what we think a Georgia Tech worker node looks like. We think it has 2 gigabytes of RAM. We think it has 4 cores. We think it has CVMFS or no CVMFS. And one of the things that really, is maybe our most frequent item is when this is slightly wrong and says, let's say IceCube requires a GPU. Or sorry, no, I'll stick with OSPool. Let's say we have a job at an access point that requires a GPU. And in the factory description, we say, hey, Georgia Tech has GPUs. So that the front end says, great, I'll send a pilot to Georgia Tech. And we start the pilot up and start an execution point and no GPU. And all of a sudden we scramble around saying, hey, we thought Georgia Tech had GPUs. You started something up that had no GPUs, and we don't have any jobs for that GPU-less execution point. And so, we try to carefully provision things, but this is one of the cases where it can go wrong, where if we say we thought in our description this had 4 cores, but we started up and it only has 1 core and we only have 4 core jobs, or we thought this resource had 8 gigabytes of RAM and we have a job that requires 7, that starts up and that has only 4. So these are, I'd say, again, maybe the most frequent ones and the ones that potentially are the most devious, because it requires looking both at all the access points and looking at the execution points and a little bit of luck to be able to look at the details and see where they go.